All right, kiddos, welcome back to the videos. We just finished chapter 1, which included conversations about significant figures, accuracy versus precision, and dimensional analysis. Now, I purposely front load chapter 1 because I want us to get that stuff out of the way. And so now in chapter 2, we're actually going to take a step back and go over the basics of what chemistry is, so talking about matter. And matter, of course, can be broken down into many subsections. I have a general outline going on the screen right now. And I'm going to just take a minute to fill in kind of what is matter and what is the first breakdown, and then we'll talk through that. First up is the important definition of what matter is, and that is anything that has mass and takes up space. So pretty much anything you can think of is made up of matter. And so matter gets broken down into two subcomponents, if you will. One is pure substance and one is mixture. Now, easy definition is that pure substance is a constant composition, whereas a mixture is a variable composition. And we have terminology for both sets of mixtures and for pure substances. All right, so in pure substances, we break down into elements and compounds. Now, hopefully it's a little bit clear what an element is. Here are some examples. So it's just looking up at the periodic table, seeing one of the elements and saying, yep, that's a pure substance because it's by itself, it's a constant composition. And compounds, on the other hand, are two or more elements combined in a chemical manner. And they are still a constant composition throughout, but it involves just a few more of these singular elements bonded together. All right, so on the mixture side, let's look at that for a second. Again, a mixture is a variable composition, and it breaks down into heterogeneous and homogeneous mixtures. So, looking at the base word of each of these, heterogeneous means that it's different throughout, whereas homogeneous means that the mixture is the same throughout. So I'm going to try and write down some examples here, because I think that helps really solidify an understanding. So, a common mixture that is different throughout, you can tell the individual parts of it, would be something like a salad. You do not look at a salad with croutons and cheese in it and say that everything looks the same. That'd be, one, really gross, don't eat that salad, and two, just unrealistic. Another one is cereal and milk. You can definitely tell the difference between what is your cereal and what the milk is. Another basic one that's pretty easy to remember is oil and water, or oil and vinegar. If you mix the two together, the oil easily separates and is very visible in its separation. Now, for homogeneous mixtures, the mixture has to look the same throughout. Obviously, I just wrote that down there, but that means you cannot identify the individual parts of that mixture once it's together. So, for example, if you mixed Kool-Aid into water, you know that it's in there because water isn't normally whatever color that Kool-Aid is, but if you tried to identify an individual water compound versus an individual Kool-Aid compound, you would not be successful. Another one is if you put milk into coffee, you cannot tell the difference between them. Again, you know it's added because the coffee is a lighter color, but you cannot say, oh, look, there's the milk and there's the coffee once it's mixed all the way through. So just some basics of, hey, what are the different types of mixtures? What does heterogeneous look like versus homogeneous? And again, some examples of compounds and elements on the side. And for one final note to wrap this all up is making sure that somewhere in your notes you have the states of matter that exist. The states of matter, of course, being solid, liquid, and gas. Now, I know that plasma is considered one, but we don't really deal with that within the realm of chemistry this year. So, these three things, you must know what they are, that they are states of matter, and we'll go through how they affect the life around us in a future video.